Good, good morning, friends. In the previous class, we have started with the discussion on the walls. Okay, so in the previous class, what we have seen, so we have seen the requirements. Okay, this one we have completed requirements, and what are the general types. Okay, so we have seen types of walls as load bearing, non-load bearing, as well as external, internal. External, internal. Generally, external will enclose means what if there is external wall like this will cover the building. If internal walls are there, they will divide the space. That's all. Okay, they will divide the space. Now, if you see this, the typical cross section of load bearing wall. Load bearing is nothing but they will take the load from the top, maybe from slab or any other floor or beam or anything. So it will transfer it to the bottom, such as foundation. Okay, that is the load bearing wall. So in this typical cross section, you can see at the base you have foundation. Next is some masonry, that is also we call them as wall only. This may be brick or concrete block or stone. After that there will be small, here there will be lintel, sorry, so what is this, sill level, sill for window like this, and there will be window frame. So jambs and reveals will come here, and there will be on the top there will be lintel, again there will be brick. So at some point we have chejja. Okay, and later you have last part slab. Okay, this is the typical cross section. Now typical cross section, so we will see in detail what are the points like this. Okay. Okay. So now load bearings are generally load bearing, first category, load bearing walls, they will carry the superimposed load. Okay. Transferred through what? Roofs. Okay. So the walls is there. So the at the top level roof will come. So they will transfer them. Okay. Apart from that, their own self weight means what? This has to be transferred. Apart from that, this its own self weight. Its own self weight has also to be transferred to the ground level. So these walls will subjected to live load, dead load, wind load, earthquake load. So all things are applicable here. Okay. So here, what is the next one? Load bearing walls are structurally efficient when the load is uniformly distributed and eccentricity of the load is minimum. So uniformly distributed means what? If this is the longitudinal section like this, longitudinal section, if the roof slab is coming, so it has to be uniform like this. Okay, like this uniformly it should come. In some places one roof will come, in some other place if it is not there, then that is called as a not uniform load. So that time here this wall is under large pressure, here it will be small pressure will be there. Okay, eccentricity means what? Coincident line of action of this wall as well as this load should be same. Line of this load, line of action of this load as well as the CG of this wall should be same. Then we call it as axial. If this line is not same, if load is coming at the edge, then it is called as eccentricity. So to perform well for wall, eccentricity of the load should be minimum. That's okay. Now next is what? The strength of wall. The strength of wall is measured by its resistance to stress, which are produced by dead load, live load and other load. Suppose if this is a cross section of the wall, suppose this is the load coming on the top. So it will exert some resistance. This will exert some resistance. Suddenly it will not collapse, no? It will not be like this, no? Suddenly that wall will not become smaller, no? Why? Because it is also resisting to the given load. So strength is depending upon its resistance. That is the meaning of this sentence. Strength of the wall, you can tell it as its resistance to the applied load, or applied stress, which are produced by what? Dead load, live load and other loads. Okay, like this. Now, the stability of the wall is measured by its resistance to overturning. resistance to overturning or buckling. Now this is a strength part. Strength part. Stability means what? If this is a wall, if this is a wall. Stability means if there is some lateral force, if there is some lateral force, the wall should not topple down like this. It should not fall like this. It should not fall like this. So this is called as overturning. This is called as overturning. If someone comes and push this wall, if it falls like this, we tell it as he has overturned the wall. So the wall is overturned. So resistance to this overturning means what? It has got some resistance such that it will stay in its position. It will stay in its position to the laterally applied load. To the laterally applied load is called as stability. Is called as stability. So here it is called as strength. Here it is called as stability. Strength is resistance to applied load. Here it is resistance to overturning. It is resistance to overturning. These two are points. Okay. Now to uniform loading. What is that? To uniform loading. Buckling is also same thing. See, buckling means what? If this is a wall, if something is applied here, the wall shape will become like this. Wall shape will become like this. This is called as buckling. This is called as buckling. These will happen in slender walls or very thin walls like sheets, plates, like that. No, if something is there, so obviously it will bend like this. This is called as buckling. Okay. Now to have uniform loading, what are the things to have a uniform loading? Suppose this is a wall. Suppose this is a wall. To have a uniform loading like this, you have a uniform loading. Openings in the walls should be small. Means what? Small openings you should provide. Bearings for lintels and bed blocks under beams should be of liberal size. Suppose this is a door opening in a wall. There should be a lintel on the top. So this distance is called as bearing. This distance is called as bearing. So this should be a little bit larger. The distance between here to here means what? The bearing should be a little bit more. For what reason? To have a uniform loading. To have a uniform loading. So that is why they are telling bearings for lintels. This is the bearings for lintels. This is a lintel. And bed blocks will come when there is a some this like structure is there, no, in the wall. There you are going to have a horizontal member like this. So this is called as bed block. Okay, this is called as bed block. Okay, corbel structure. Okay, there is a corbel, no, so there you are going to get this bed blocks. So those bearings should be liberal size. Liberal means what? A little bit larger size. Liberal means a little bit larger size. So lintel should be larger, that bearing, as well as bed block. That bed block is there, no, for corbel structure. This is a wall. This is a corbel. So bed block will come here like this. So bed block, above that there will be some load transferring member like this. This bed block should also be a little bit larger, and bearings for the lintels should be larger. This is a lintel. Okay, so there is a door. Okay, door opening like this. Door opening. This is a door open. So on the top there will be lintel like this. Okay, this should be a little bit larger, this distance, for having this. Heavy concentrated loads should be avoided. There is a problem if suddenly on this wall, suddenly large load is applicable on some point, this will make shear cracks. So avoid this heavy concentration. Okay. Sections of load bearing members should be varied with the loadings to have uniform stress in adjoining parts. To have uniform section in adjoining parts. Suppose this is a typical wall. Here you have larger width. I am drawing the three-dimensional diagram. So here you have a larger width. This is have a smaller width. Okay, this is a larger width, thickness. So what they are telling is that if this part is under heavy load, so you provide larger thickness. If this part is small load is acting, so provide smaller thickness. Why? It will lead to same pressure. same stress inside this one. Okay, so that is why depending upon the loading you increase or decrease the thickness. That is what they are telling, increase or decrease the thickness. And very important, very important, eccentricity you make it as minimum as possible. In one point I'm telling, so don't get confused all the statement. You understand only minimize eccentricity, that's all. Minimize eccentricity. Okay, so that is a very important. Now, in load bearing wall, you have solid wall, cavity wall, faced wall, veneer wall. In load bearing walls, you have so many categories: load bearing solid, load bearing cavity, faced, veneer. Solid means what? If this is a wall, if this is a wall, and if you draw the cross section, if you draw the cross section like this total will be full. There is no empty spaces here. The total wall itself is made up of units. Units may be bricks or stones. Anything is possible. Whatever the thickness you are providing, no, you are providing full solid masonry units. There are no hollow spaces. So those are called as solid masonry wall, no empty space. So it is made up commonly used, solid masonry wall commonly used. So individual blocks such as bricks, blocks, stones are used. So generally these are laid in courses joined by mortar. So this line is totally studied in masonry chapter. Okay, how the courses are laid, how the mortar is placed. Okay, sometimes to have access we provide what? Doors and windows. It is not at all possible that throughout the building doors cannot be, sorry, walls cannot be solid. Somehow in load bearing walls also we should provide doors, we should provide windows. Why? For ventilation, sound purpose, okay, air movement, access and movement, everything we require the openings. So above the opening we generally provide what? Lintels. For what reason? Again for stability purpose or strength purpose. Okay, so in solid masonry wall also we can have doors and windows, no problem. Generally, the main door is itself located in solid wall, which is load bearing wall. External wall itself is a load bearing wall, no? Generally. So that is why it is provided outside. So solid bearing wall. Cavity wall means what? If you take the cross section, if you take the cross section like this, okay? So there will be some hollow space like this. There will be some hollow space like this. So one side there will be half of the wall, okay, and that side also half of the wall, okay. In between you have some opening or gap or some vacuum kind of a empty space you are providing here, okay, empty space. So generally empty is called as what? Emptiness is called as here cavity. So your teeth has cavity means what? Cavity is nothing but some holes, no? So in the similar way, in the given wall, if you have some empty spaces, okay, in between, it is called as cavity wall. Cavity wall. It acts as a barrier. This is a barrier. Suppose this is exterior surface, okay, outside the building. Suppose this is the inside of the building, okay. So heat will not come and pass through this barrier. It will not come and pass. Moisture will not pass through this barrier. Sound will not pass through this barrier. So it acts as what? Insulator. Cavity walls are generally insulating walls. Insulation for what? Sound, light, sorry, heat, temperature and moisture. Sound, heat, temperature, moisture. So for them it acts as an insulator. So it is telling at what? Cavity walls has two leaves. First leaf, second leaf. Okay, like this. Two leaves. Separated by cavity, which is separated by cavity. So here separation is there. Okay, tied together means what? Some tyingness is also there. Means what? Two separate things are there, no? Two separate things means what? They will tie. First unit, second unit. Okay, like this. Some metal piece will be there. They will join like this. Somehow there is a joining portion. Okay, such that two leaves act as one structural unit. Later on, when you place some roof and all some load is there, no, so this total will act as one single unit only. In structural part there is a cavity, so that this is a leaf 1, leaf 2, two leaves. Okay, so but when you say load is acting, but it acts as one single unit. That is the advantage of having cavity walls. So two leaves are present, separated by a cavity, joined by some metal ties. Joined by some metal ties. Okay. Now the space between is kept empty or filled by what? Maybe filled by waterproofing material, or maybe it is empty itself. Maybe it's empty. Maybe some insulating material is also present. So both way everything is also possible. What is this faced wall? Faced wall is what? It has got facing material, backing material are two different materials which are bonded together. Which are bonded together. Means what? Suppose there is a building. Suppose this is that wall, faced wall. What is happening here? Inside finishing or material may be different. So inside may be different. For the same wall, when you see it from the outside, the finishing and the materials used may be different. Finishing and material used may be different. So that is called as faced wall. That is called as faced wall. Now what is this? Veneered wall. Veneered wall means what? Facing is attached to backing. Means what? This is somehow it is attached. These two are facing material, backing material are attached to each other, but not so bonded. Means what? Bonding is not so good. Okay, architectural purpose. But faced wall is somewhat structural purpose. Structural means load carrying. Veneered means what? Non-load carrying. Okay, veneered means not load carrying. So these four are the different types of walls. Cavity wall very important. So this is, let us see first diagram cross section of that cavity wall. What is happening here? Here cavity wall. This is a typical cavity wall diagram. What is that? So foundation is there. This is leave 1, this is leave 2. So some masonry is there. Generally some masonry is there. In between this is a cavity. No, this is cavity, this is cavity. What is happening? After construction of this part and this part, they are joined by some what? Metal. They are joined by some metal ties. Okay, so above that they have placed what? Window frame. Again, this is what I expect you to give the answer. The portion which is coming on the top of window or what is that? Window and door is lintel. Again, after lintel, some more height masonry is constructed and it is joined by some metal pin. There will be slab. Okay, this is a typical cross section of cavity wall. Okay, so cavity is there, metal tie, masonry, that is wall, so window frame. Okay, so that one only explanation we can give here. Okay, so there is two separate walls, we call them as leaves. Two walls, we call them as leaves. Center, there is a gap or cavity. Two walls, we call it as leaves. Center is a cavity, we call it as a gap. Okay, center is a cavity. So generally they are equal thickness. This side and this side both are equal thickness. For what reason? To act as a structural. To act as a structural. Okay. So joined by metal pins, that is there, joined by metal pins. Okay. So generally these should not be less than 10 centimeter. Each wall thickness should not be less than 10 centimeter. That is the one point. So there is a huge advantage. Okay, we will discuss this one in the next class.